Good morning to all. Electrical machine design EMD topic steps for calculation of air gap length. First, calculate the field ampere turns for no load. ATF naught is equal to ATF minus field ampere turns required to compensate armature reaction full load. Second step, calculate the field ampere turn for the air gap. ATG is equal to ATF naught minus ATI. Steps for calculation of air gap length. Third step, determine the maximum flux density in the air gap. Maximum flux density in the air gap BG is equal to B average divided by KF. Steps for calculation of air gap length. Fourth step, assume suitable value for air gap coefficient Kg is equal to 1.15 to 1.19. Calculate the field ampere turns for the gap per meter of the gap length. ATG is equal to 0.796 Pg Kg into 10 power 6. Sixth step, calculate the length of air gap. Lg is equal to ATG divided by small ATG. Continuation of steps for calculation of air gap length. Sixth step, B real is equal to actual flux in a tooth divided by tooth area pi t divided by AT. B apparent is equal to total flux in the slot pitch or total air gap flux divided by tooth area. B real less than B apparent. B apparent is equal to B real plus 1.257 H bracket of Ks minus 1 close bracket into 10 power minus 6. Electrical machine design EMD problem topic steps for calculation of air gap length. Questions problem, calculate the apparent flux density at the armature tooth section of DC machine from the following data at that section. Slot pitch is equal to 2.5 cm. Slot width is equal to 1.2 cm. Length of the armature core by including 5 ducts, each 1 cm wide, equal to 45 cm. Problem continuation. Question, each 1 cm wide equal to 45 cm. Core stacking factor is 0.92. Real flux density in the tooth at the section for which ampere turns required per meter is 17,000 equal to 2.2 Tesla. B real, that is 2.2 Tesla. Theoretical classes steps for calculation of air gap length formula is given. Following that formula, design that problem. Given B real value is 2.2 Tesla, H 70,000, length 45 cm, number of ventilating ducts NV is 5, width of ducts BV is equal to 1 cm, tau dash 0.5 cm. That is given values. Slot pitch Ki is 0.92, that is stacking factor. Bs is 1.2 cm, that is slot width. Formula, Li is bracket of L minus NV BV close bracket Ki. Put required values V of and Li is 0.368 meter. Bt dash is towers dash minus Bs. 2.5 minus 1.2 is 1.3 centimeter. Solution continuation. Bt dash is equal to towers dash minus Bs. 2.5 minus 1.2, that is 0.013 meter. Ks. Put Ks formula is towers dash into L divided by Pt dash into Li. In this formula, put required values V obtained. Ks is 2.35. B apparent formula is equal to B real plus 1.257 H open bracket Ks minus 1 close bracket into 10 power minus 6. Put required values V obtained. B apparent 2.32 Tesla, that is greater than B real. The condition satisfied. Design finished. Electrical machine design topic steps for calculation of air gap length. Problem 2. Calculate the apparent flux density of a DC machine when the real flux density is 2.15 Tesla. Slot pitch is equal to 28 mm. Slot width is equal to 10 mm. Gross core length is equal to 0.35 meter. Number of ventilating ducts is equal to 4. Width of each duct is equal to 10 mm. Ka is equal to 0.9. The magnetizing force for a flux density of 2.15 Tesla is 55,000 ampere per meter. That is question. Solution. Given value B real is equal to 2.15 Tesla. Towers, that is slot pitch, is 28 mm. BS is 10 mm, L 0.35 meter, NV is 4, BV is 10 mm, KA 0.9, H, capital H is equal to 55,000. LI formula is bracket of L minus NV BV close bracket into KA. Put record values we obtain. LI is equal to 0.279 meter. Solution. BT dash is equal to towers minus BS. 28 into 10 power minus 3 minus 10 into 10 power minus 3.018. KS formula is towers dash into L divided by BT dash into LI. K's formula is towers dash into L divided by BT dash into Li. Put required values we have and K's value is 1.95. B apparent is equal to B real plus 1.257 H into open bracket K's minus 1 close bracket into 10 power minus 6. Put required values we have and B apparent, that is 2.22 Tesla, that is greater than B real, that is condition satisfied. Design finished.